Hello students, I am Bhumica Verma, Assistant Professor in CSE Department in Ajay Kumar Engineering College, and today I am here to teach you about resolution refutation method in prepositional logic that is used in AI. And believe me guys, this is a very important as well as interesting topic and a very important point of view of AKGEC exams. So this is a very important topic that I am going to discuss, and in this lecture I'll try to explain each and every concept of the numerics in the form of you can say that points that I'm going to discuss while resolving the problem, while having the questions of resolution. So let's start with, to begin with, I must say the basic introduction about the topic, that is resolution. So basically this is a theorem proving technique that proceeds by building the refutation proofs. One by one I will take up these words, what these actually mean. So these are the proof by contradiction that was invented by a mathematician, that is John Allen Robinson, in the year 1965. So in that case, a resolution is basically, you can say in very simple and layman term, that resolution refutation method is basically the proof of something equal to something. That means in this technique we are trying to prove something equivalent to something. So basically this is a resolution refutation method. And how it is going to work, let me explain in the next slides also. So basically a resolution is a single inference rule which can effectively operates on the CNF or the clause form, and clauses are the disjunction of literals, and it is also known as a unit clause. And finally there will be a CNF, the sentence that is represented in the form of conjunctions, or it is said to be conjunctive normal form or CNF form. Now, as you have seen in the slide, that there are very important terms that are being represented, that is in the form of, you can say here the term is unification, that is important term here, then clause, and then the CNF form. So before going to teach about resolution, I must tell you about what these terms basically means, because these terms will help in problem solving of resolutions. So basically, starting with the clause. So clause is basically a prepositional formula that is formed from some finite collection of literals. Those literal could be any of these. That means it could be a constant, variable, predicates and function, connectives, equalities or quantifiers that must have been studied before. So basically, let's have some example. Suppose I'm saying that Ravi and Ajay are brothers. So basically, this is being represented in the form of brothers. In the parameters I have Ravi and Ajay. So here brothers is taken as a predicate here, and Ravi and Ajay as a parameter says that Ravi and Ajay both are brothers by in nature or relationships. Second is every man respects his parent. That means it is represented with the form of some quantifier, because it is talking about a general form, that is every man. So every man will be represented by this quantifier, that is all quantifier, and that says for every x where x belongs to man and that x respects his parents. So this is being represented like this way. Then third one, some boys plays cricket. So here is also a generalized term, some. So some is being represented by the quantifier, that is existential quantifier, which is represented here x, where x belongs to that boys category, which says that those x play cricket. So these are basically how a clause is being represented, or you can say that these are simply the representation of how a simple statement is being converted into prepositional logic. Now the next is, what is unification? So unification is the process of making two different logical atomic expression identical by finding a substitution. Now what this means? This simply means that if there is a predicate, suppose P, suppose this is an example, suppose P is having a predicate x and y, and the x and y are the parameters of this predicate. Similarly, the P is having another two parameters itself, that is A and FZ. So that means both these clauses represent that P is the common clause between them, and the parameters that are represented x, y, and here the parameters are A, F, Z. So that simply means unification says that I am able to substitute this x with A or A with X. Similarly, Y with FZ and FZ with Y. So basically, unification is that kind of substitution, that I am substituting that thing. For this, there must be some conditions. So condition says that the predicate symbol must be same. That is also because I am having these two statements. So then simply says that predicate is both identical in both the statements. Similarly, number of arguments or the parameters should be identical. Similarly, here also two expressions are there, here also two arguments are there. That means the parameters are same, the condition is fulfilled. Third condition says the unification fails if they are two similar variables. That means if I am saying that there is a p xy and here is a p that is x and you can say suppose karo L. So in that case, the predicate is same, parameters are same, but here the arguments lies is same. That means here also x and here is also x. So you cannot take the same term name. That means the name should be not identical in that case. So these are the conditions of unification. So next is I have studied about what is a clause, what is a unification. Now after studying about this, now I'm coming up to the resolution, that is the main concern of this lecture. So what are the steps for resolving the things? So the first step is you have to convert the fact into first order logic. That simply means that if I am writing a statement that I have studied that Ravi and Ajay are brothers, that is simply a fact, that is simple statement. Now I have to convert that statement into prepositional logic. So that prepositional logic is known as FOL form of that sentence. So the first step that you have already understood, that I have to convert that simple sentence into some prepositional logic. That is okay. Then the second is convert that FOL statement into CNF. And what is CNF says, I'm going to explain you. Then negate the statement that needs to be that the proof of contradiction to be resolved. Finally, draw the resolution graph. And then to better understand, I'll take an example. So before going to take an example, I just want to tell you about this CNF form. What is the CNF? So CNF is basically a normal form. So basically, I'll try to explain you. Normal form basically means if a clause is constructed, that clause can have either of the connectors. That means it could have this symbol, that means AND operator, OR operator, negation operator, implied operator, double implied operator, quantifiers in the form of this way. So the clause can have all these connectors at oneself, but this normal form says I have to resolve all these operators. The normal form always only include these three operators. That means AND, OR and negation. That means all the other operator except these operators must be resolved. That means they must have some formula and they'll be replaced by that formula. So normal form says that there will be only these three connectors in the clause. Similarly, the normal form are of two types, that is CNF form, where what I am talking about here, and DNF form. In these normal form, this is conjunctive normal form, this is disjunctive normal form. This says that the clause will only have this as a symbol as well as negation as a symbol. And in this form, it says it will have this as a symbol and negation as a symbol. Which means that if there is a clause, suppose there is a clause like that means this is seen in the clause, that this clause is having this operator in between. That means the main attraction will be this connector and it could have any negation in it. That means the negation could be placed over here or it could be placed with this B. So here there will be two possibilities that I have to keep in mind, that this connector will be in between the CNF form, and when I'm talking about DNF, this connector, that means OR connector, will be in between that form. And about negation will be taken into consideration in two ways. I have to find out whether that negation is coming internally or externally. That means if it is coming internally, that means if I'm writing like this is okay, that element B is there and its value is being negated. But if there is a case like this thing, and this is being negated. That simply means, and then I have to resolve this. I have to write it like negation of A, and this symbol is being reverted, and it will be like this way. So simply this is being resolved like this way. So keep in mind these two things, that when I am talking about CNF, only these two operators will be coming in the clause, and if I am talking about DNF, only these two operators will be coming in the clause. If they are not, then I'll try to resolve that statement using some formulas, and I have to bring these connectors only in between that clause. So moving on, I'll say first example of resolution. So the first example says, suppose there are two statement, English like statement, that if it is a pleasant day, you will do strawberry picking, and second says, if you are doing strawberry picking, you are happy. So these two statements are converted into some prepositional logic, which simply says that if it is a pleasant day, if, so this implied symbol says if it is, then you will do strawberry picking. Similarly, if you are doing strawberry picking, then you are happy. So these two statements are being converted into prepositional logic. That is the rule number 1 that I have already told you. Now we have to convert these statement prepositional logic into some CNF, because I have already told you that prepositional logic statement can constitute of these symbols. But if I am talking about CNF, that these symbols will be replaced. So that means I have to replace this symbol, I have to replace this symbol, and this symbol will be replaced by some formula, and that formula is basically like this way. If I'm talking about this, so this is basically the discrete formula that we have already studied. If not, you can caption from here also. So that simply says that means this statement is being replaced, and it will be replaced in the form of the formula that I have studied. So it will be written like this way. That means strawberry picking or not pleasant, and finally this statement is being converted this way, and these two statements are connected with a symbol, and this symbol is that symbol which I am talking about, that whenever CNF will be coming, then the clauses will be connected with this connector, that is AND connector. And finally, when I am having that CNF form, that you can see here two symbols are there, this symbol, that is important, this symbol and negation symbol. And about negation symbol, because negation is coming with only a single element, so it need not to be resolved further. And the main goal, that is I am having that AND operator in between the clauses. That means I have converted the right CNF in that case. So after taking these statements, I am just trying to cancel out the conflicting terms, and conflicting terms are basically the terms which are saying that doing of something and not doing of that thing in the another sentence. That means if you will see that strawberry picking is coming here and not strawberry picking is coming here, so I can cancel out these two terms. So these are the conflicting terms, and I'm cancelling out that thing. And finally, I'll left out with not pleasant thing and happy. So I have a new clause, not pleasant and or not happy. So I can because this is a proof of a statement, so it will be finally written like pleasant. Pleasant implies by happy, or pleasant implied by happy. That simply means if it is a pleasant day, you are happy. So this is how the resolution is being done. That means simply means if there is a statement, I have to convert those statement into some prepositional logic. Secondly, I have to convert it into CNF. CNF says that it should have include the AND symbol or negation symbol if it is necessary, or then finally some information is being carried or being implied or referred by the above statements, and finally I have written a clause that defines the resolution of these two statements in the end. Then next is the reference rule, resolution inferences rule, that I have mentioned in the first slide. That means how to resolve that thing. That means whenever these symbols are coming, the first priority will be given to this double implied symbol. This double implied symbol will be replaced like this way. Again, when I am saying that double implied symbol leads to some implied symbol, so that means converted into CNF, we have to resolve this also. So for resolving this, I'll go to this statement and this formula. Again here, because negation sign is coming, I have to check out that this negation sign is coming internally or externally. That I've already told you. Then finally, I should apply the De Morgan's law, which says the De Morgan's law simply says, if negation is coming externally, then I have to change the statement likewise. That already being studied in various of the subjects we have studied, that is DSDL or either DE. And finally, after some statement is coming like this way, so those statement have excluded all the other symbols. But if these symbols are coming, I have to solve, or I have to write the clause in such a way that my goal should be achieved. That means I have to achieve the CNF form, or I have to achieve the DNF form. So my clause will be written like that way. So that will be helpful when I'll apply the distributed law in it. So for solving this, for making you clear about the concept, I am taking some example for that. So basically, some of the examples are here. So I'm taking the first example. I have to convert this prepositional logic statement. This prepositional logic statement is being converted into CNF. So taking this as a statement, I'm saying, so first of all, I'll try to solve this thing. So this simply says double negation, because as you have told, this is being referred to OR symbol. So double negation of and A and negation of A, and this thing is being done. Okay, so here again, this is C and negation of A. So when I'm solving this, this comes up with A and this way. Now my motto have been achieved, that the symbol and is coming in between, and here wise this negation symbol is associated with only the single element. Here also the negation is associated with the single element, so I need not to resolve this problem furthermore. So that's it, and this is being solved in this way. Now this as an example, if I'm taking this example 2, this will be referred to, that means because this is in the bracket, so this will be given some priority and this will be solved, and this will be written like A or B, and here it is referring to C. In that case, this will be written like negation of this thing or C. Furthermore, this is being again resolved, that means A, the symbol is reverted, then this is B, and here this thing. Now I have to say, let's see, here the operator is OR, but I have to convert it into CNF, so that means I have to resolve this thing. So distributive law will be applied to this. In this case, it will say A or C and A negation of B. So here my goal is achieved, my connector will be AND here. So this is how this question is being solved. So this is converting into DNF, that means I have to take care of the middle connector, and the middle connector is this thing. So that means my goal is to change or to resolve it to get OR operator in between. That will be solved in a way like my priority is to work out for this thing. Then resolving this thing means simply the De Morgan's law is applied. Similarly, after applying this De Morgan law, this will be achieved. Similarly, this implied symbol is being resolved with the help of that formula. Now again the operator is an in between, so in this case I have to apply the distributive law. So I'll take this as A and B, C. So this formula will be taken into consideration, and finally my goal is achieved, and in between I'm getting a symbol or operator. That means I have achieved to the DNF form of the thing. So this is how CNF and DNF statement is being converted. Now moving on, what is refutation? Because the second word is of the lecture is refutation. What is refutation? Refutation simply says, as resolution says, that there are some statements and I have to derive some information out of those statements by converting into FOL, then CNF, then I'm deriving some knowledge out of it. But refutation says that with the group of statement, there is also a goal given in the statement. That means I don't have to imply that knowledge. I don't want to take that knowledge out of those statements. I have to reach to that goal that is given in the question. That is being cleared with the help of an example. Suppose say, this is an example. So this example says that to resolve with the help of resolution and refutation, how it is working. So the first statement is English statement. The previously I have told you that there will be given some group of statements. Those statement will be converted into some propositional statement that should include any of the symbol, like this symbol, this symbol, this symbol, this symbol, implied symbol. But whenever I am converting it into CNF form, these symbol will be resolved, especially this symbol, this symbol will be resolved. In the case, this thing will be applied. That means somehow this statement will be written like this way. That I need not to explain it further because I have taken some examples, so you can try it yourself also. So finally, I have got some steps. You can say 7 statements, some prepositional statement that is coming out of these statement, English-like statement. This is how the process of resolution is working. Simply, if I have to say ki do this question with the help of resolution, I'll derive some information out of it. That means if the exam question says that convert these statement into FOL, that you simply derive these statement into prepositional logic. But when you are questioned to change into some CNF form, that you have to convert or you have to resolve those statements into CNF form with the help of some formulas. But now if they asked you that you have to resolve with the help of refutation, in that case what will you do? Then in that case this thing will also be given in the question. That means some statements are given to you like this way, and they will ask you to they'll give you this English statement and they'll say that you have to achieve these goals. That means in the question there will be 2 consideration. That means the group of statement as well as the goal, and you will be questioned, you will be asked that you have to prove this with the help of refutation method. In that case, what will you do? Refutation process says that you will contradict the goal statement, because if you want to prove something, then you have to negate something. In that case, whatever will be the goal statement, that will be negated and it will again added into the premises. That means the given English statement is being extended with the negation of the goal statement, so that I'll be able to prove whatever I want to prove, because ultimately my goal is to prove something equal to something. So to prove that something equal to something, I need to change something. So I cannot change the question. So what I'll do, I'll increase my knowledge base database. So for that increase of knowledge, I'll increase the English statement. I cannot increase English like statement myself. So whatever information given the question, I'll increase my knowledge base with the help of those things. So that means I cannot take this thing into the premises. So you can say that this statement is coming, that means the goal is achieved, because you will say the 7th statement claims this, so the goal is achieved. But this is not the case. If the goal statement is given, so you cannot take this goal same as it is into the English like statement, you have to change it. So the addition will be like this way, that you will negate the goal. So if I'll say the goal 1 is, if you are saying that you are not doing strawberry picking, so first of all again do that thing, that I have to prove this is an English statement. Then for proving, I have to convert into FOL. I am converting this is being converted. If this English like statement, if this FOL is again having some kind of connectors that needs to be resolved for CNF or DNF, then it should be resolved first of all. If not, then simply I want to prove this thing. If I'm proving this thing, then I have to assume something from this proof. So what I am assuming just the negation of this statement. That means I'll assume not strawberry picking is the proof. So I'll assume strawberry picking as a assumption, and I'll add this assumption into the English-like statement. So I'm keeping this assumption one side, and from these statement, I'll choose that statement that is having the negation of that statement. That means if you are able to see, the third statement is somehow claiming that negation of strawberry picking in some way. So I'll keep the third statement here. And again, the process of contradiction, that means conflicting terms, will be cancelled out. So that means strawberry picking is being cancelled out against not strawberry picking, which comes up with the not raining term. Now, not raining term is, again, if I infer to this information, the sixth statement claims to be raining. So I keep this sixth clause here, and again cancelling out the same term. And finally, in this way, I am getting some empty clause. This empty clause is the proof of refutation. That means you have achieved whatever the goal is being given to you. That means you have achieved the goal. That means refutation process simply says that whenever English-like statement are given and a goal is given, then you will just negate the goal. You will simply put that negation of goal as an assumption, and you will one by one taking the clause with it, cancelling out the conflicting term, and finally you will reach up to a empty clause, and this will be a proof against the refutation. So this is how this is achieved. The second thing is you will enjoy. So you will enjoy simply says, simply FOL is enjoy. Enjoy, then assume that not enjoy. So I'm keeping this not enjoy here, and in the statement I'll find out where the enjoy is coming. So if enjoy is coming in the first statement, so I'll take the first statement, and in this way negation of these two things are cancelling out, and I am left out with this term only. Now I'll check the clause where it is coming. So not warm, fifth clause is having warm only. So I'll taking up the fifth clause here, and I am again cancelling out the term here. Finally, I am left out with not sunny. I'll find out the clause that is having the negation of it. The seventh clause says this key, there is a sunny. So that simply means negation of sunny, sunny, and sunny is being cancelled out. And finally, I'm reached up to the empty clause, and this is how I have proved the thing. So this is what the refutation method says. So if this is clear, I'll take one more example. It will be more clear to you. So here again, the example, some group of statements is given as it is being given in the AKGEC exams or whatsoever exam you are giving. So there will be a group of statement, and you will be again instructed that you have to solve this question with the help of resolution refutation process. If refutation is there, that means here again a goal must be given in the question. So here the question says that you have to prove that John liked peanuts. Although as a human we can conclude from these statements John like peanut, but because this is an method, resolution refutation method is a method that is used in AI and very common and important aspect. So I have to prove with the help of these method which I have studied in the lecture here. So these statement will be first of all converted into FOL. So this will be the conversion somehow. Okay. Now the second step is I have to resolve these parameters. That means these connectors I have to remove. If I am to convert it into CNF, by default I have to convert it into CNF. If it is given in the question that you have to convert it into DNF, then I'll think about that way. But if it is not given, then first of all I'll try to convert these implied symbol into some CNF form. So that means simply says that I have to resolve this thing. So finally I have resolved these things, and then what? I am moving the negation sign. That means I'll check out with the negation sign internally or externally. Then finally I try to rename the things, and then universal quantifiers are being dropped out, and finally I try to make that resolution graph. That means I'm taking the clause one by one. That means what I am going to prove is being negated, then I'll take one by one clause, cancelling out the common conflicting terms, and finally I've reached up to the conclusion that the clause is being empty. And finally you can say the conclusion is I have the complete contradiction with the given set of statements. So I hope the concept is being clear in every aspect. So this is all about the lecture. I hope you like the lecture, and thanks for watching.